This video is a continuation of trying to set up a Raspberry Pi and your rig so you can remotely hook up to the transceiver and receive and send CW or sideband or AM or FM. Right now we're on sideband, lower sideband, on 160 meters with the rig actually attached to a dummy load. So I turned up the RF a little bit, gain on the receive so you can hear that static in the background. You're looking at the Raspberry Pi desktop. This Raspberry Pi is running headless, and so it does not have a monitor. It's using a USB sound card. In fact, this USB sound card is already included in the rig. It's a Elecraft K3S. So it has line input and line output, and that's what we're using for jack audio. That would be the system for the line output, and on the left side and on the right side, system for the line input. We're using the Raspberry Pi's own sound card to send a audio-derived CW keying voltage, audio signal to activate an audio-derived push-to-talk and CW keying circuit. So on channel 1 we have a CW jack attached to a transistor that is activated by the audio voltage sent to it at a certain level. Same thing for 2, only this activates the push-to-talk button, the push-to-talk circuit on the K3. And what this allows us to do is have full Vox control, and I'll go over that in a second. Right now I'm going to play an audio file, and we're going to adjust the speech audio frequency bands and see if we can clean it up a little bit or make it a little bit better.
Rob, you wanted to mention something.
Yeah, the name had escaped me as you were taking us to the break, and I was like, no, I have something else to say, but I couldn't remember the name. But I looked it up in the middle when we were taking the break. There's a company that sells hardware that when I finally did bite the bullet and have to start doing stuff with the iPad, which...
So it's just a bit of an EQ here, using this LV2. All of these plugins that we're using on this Linux laptop uses LV2 plugins. I'll go over those in a second. So here's a graphic equalizer plugin. It's an LV2 plugin. And we have it set on these frequency bands here. And it's just trial and error. You play a file, listen to it. And what you're actually hearing is the audio after it reaches the K3S in the other room. And it goes through its own monitoring circuit coming back to us. And how we're doing that is that ZITA-NJbridge. So I'm piping audio from this laptop where the video is being recorded, and it's going to the Pi. So both the Pi and this Linux laptop can use the ZITA-NJbridge just fine. I'm using Mint 17, and on the Raspberry Pi, it's a Raspberry Pi 2B, and it is running Raspbian Jessie. So the EQ, you may have noticed, without this EQ right here going, and we turned it off, then there were some extra frequencies we really didn't want to transmit, and we also cleaned up, I thought, the audio just a little bit. So let me show you the pathway here for this. Here's Zeta, coming into the laptop. And on channel 1, and I'm running 3-channel audio with the ZITA-NJbridge. Channel 1 is for Morse code. So we receive Morse code out of channel 1. Goes into this filter, out, into this DJ fader. Let's see if I can fire this. So to the right is SSB, to the left is CW. And I'll play some CW, you can hear what that sounds like. And I have another filter for that, if I can find it here. And it's this filter right here. Okay, so I'm going to play a file here. So that cleaned it up a little bit. So that's helpful for the Morse code side of things. The CAF filter is a set of LV2 filters. Lots of different ones you can choose from. I'm using, if I can find it here again, JALV.select, which brings this up. You just type in here a letter and you can find them. This has a lot of LV2 plugins. So let's go over the pathway from the laptop to the Pi. So here's FL-Digi right here. Here's where the audio from that media file is coming through. I have a test tone to help set up things. That actually is what helps to activate the gate. The gate controls the push-to-talk. This gate does. This gate controls the push-to-talk on the K3 through this Zeta from Jack to the net. So J to N to the network. This is set just a little bit lower than the threshold for the gate, so it doesn't activate it. And then the audio coming, if it was my mic, I could have the mic diverting from here over to there. So that audio, and the example we just used, it was the audio from that media file coming out of the Pulse Audio Jack Sync that went into this upper channel. Since this is stereo, this works pretty good. So it comes in here, that activates the gate, and the gate lingers a bit so that you can adjust that. So let me see if I can bring this up, if I can find it. So let's bring this media file back up and then watch the gate. And that was at CW filter, so let me turn the filter back. So now we're using the graphic equalizer and not the CAF filter.
I was looking for a MIDI interface.
Wait. What was that? You said something.
I said I've grown to like it. I didn't say it's replaced my DAW. I didn't say.
The biggest one, though.
So you heard that pause and then it returns. You can adjust that from the release time here. So on the K3S, it's not using Vox. So we're activating the push-to-talk just before the audio is sent. And then it lingers because the gate holds it open just a little bit longer. And then that test tone keeps running. We have the test tone lowered to about -5. And that's where you see this right here, through the way the things work here. We also found on the CW keying circuit and the push-to-talk circuit, we find the resonant frequency that activates it with the least amount of power. And for that switch I have in the other room, I have two different ones. 3.4 kilohertz seems to be the voltage it responds to the best, or the frequency it responds to the best. So as long as it's not above this threshold, which is right here at this corner, then it does not allow this test tone audio to pass through. So here's the gate, here's the test tone, again on channel 2, and when we send some voice audio through channel 1, that activates a gate, releases both channels, then this test tone goes through right into the second channel of Zeta, jack to N, and then on the pi, the second channel here goes to the push-to-talk CW keying circuit output. This is the analog output of the Raspberry Pi. So that makes good use of that audio jack that otherwise is just sitting there not doing anything. And the audio that it does have is pulse code modulation, so it's not really a true sound card. So I thought this was a very good use for that, to activate the push-to-talk and the CW jacks of the rig. So the audio comes in here, that test tone comes in here, and it's just enough power and a little bit more to activate that push-to-talk, and that push-to-talk stays closed as long as the gate remains open. And find that gate again. There we go. Now this is another test tone I'm using up here. And that's how I was able to set the levels. So coming out of the gate here, everything is adjusted so that it's pretty close to 0 dB. And at 0 dB, audio voltage and current audio power, that's what's going to the push-to-talk circuit right here through the Zeta jack to N2. Now we're also delaying the voice audio because it takes about 40 milliseconds to fully open this push-to-talk jack by the time this audio voltage goes out, goes into the system, and for the inherent delay in the K3S, by the time you hit, you close the jack before it actually activates. Anyway, it took about 40 milliseconds here on this delay line, so that nothing of any syllable that starts out gets chopped off. And this was also tested using FL-Digi at 120 words a minute at a 10 millisecond DIT, so that the least amount of delay, which was about 40 milliseconds, you get a perfect 10 millisecond repeat from the monitor circuit. Anything less than that, it starts chopping it off. So that was a pretty easy way to determine this. Now the test tone I have up here was just sent in so that I could adjust this amplifier. Now you have to be real careful with how much audio power you bring to your rig's input, the line input. If you get too much, you're going to activate the ALC, get some distortion. So every rig has its own rules there. So I particularly like to just get it before the ALC is activated, especially on Morse code here. Otherwise, you'll start getting a little distortion when that ALC activates, and you see a little upper swing on the beginning of the wave that goes beyond the rest of the wave. So it's a little spike. And that's totally taken out if the ALC is not activated. So this is just a trial and error, and it took about minus 15.5 dB. So that's what, if the audio comes out of the gate at 0 dB, minus 15.5, all the audio voltage arriving to the line input of the USB sound card on the K3S is just right so that the ALC is not activated, and yet you still get a full 100 watts of power out of the rig if that's your power level. So I was able to check that, and this is what seemed to be the right amount of attenuation of that audio before it gets to the line input. We're also able to see it through this oscilloscope here, so I'll bring back the audio again.
I was, in my mind, I was a player. I was a musician, even though I spent a lot of time in the studio as an engineer, as a producer.
And you can look on the meter here on this side, just so you can see a little bit. I have it set at 20 watts going to a dummy load.
I made, a fair amount of my living from being a player, and I was on.
So I have the rig on 0 compression, and I'm trying to process all the audio before it gets to the rig. And in the processing of that audio, right now we're just using the gate and the delay line. So you could also take it through a compressor, an EQ. Now on the return path, I have this EQ as an example. So this is useful for a transmit as well. So you just listen to your signal. So I could have dropped this down to the transmit side, but I wanted to do it this way. Same thing for your CW. So anything you're broadcasting, in this particular instance, since we're in lower sideband, we're using AFCW mode, so we're sending an actual signal. So I'll send some Morse code. You can see what that looks like on the scope. Okay. So without that filter, there'll be just a little bit of get extra harmonics, you get some frequencies in there that you really don't want to send, especially in AFCW mode. Now to key this normally, again we would just send a signal into this number 1. So if I can bring this out here, see if we can get that done. Now, I don't know if I have the Morse code on Vox. I have the SSB with no Vox. Let's see what happens here. Now, this is a good way to test and see if the Vox is working. Now we have to change on the Raspberry Pi. We have to change the mode on the rig here. Okay, so now we went to CW. Yep, so let's take a look at the scope. So this is on CW Vox, I believe. Now, where's the scope? There we go. And we'll send it again. If we want to monitor the side tone, then I'll do it this way. So on FL Digi, it's a pretty good example, because you want the full volume going to the ZITA-NJbridge jack to net, so that it has enough power to activate that CW jack keying circuit that's taking the audio, rectifying it with some diodes, and storing it in some caps. It's that voltage is connected to the base of a transistor, where the emitter and the collector are going to the CW jack of the K3. So I'm going to we'll just bring this both down to 0. So we're going to, on the right channel, we're going to send a 1K tone to that CW jack. And on the left channel, since it's using stereo now, on the left channel will be just the normal shaped tone. So let me set that up here. We're going to take this this only affects the left channel when it's set up like this. So I'll take this down a bit so it doesn't come out too loud. So here's the video. So we have the left channel going to 1. So we're going to change that and make the right channel going to 1. And we're going to take the left channel and go to the screen recorder and go to the system here. And let's send a V. Alright, let's look at the scope again. You can see the needle moving there, so everything's working good. The waveform is well constructed, and that's keying CW normally. Now if If you don't have FLDigi or you want to use some other CW keyboard, you can still do it. You just have to put an attenuator so you don't blow out your ears, because you want it to be as loud as possible going into that CW key circuit, which is channel 1. So that's running Morse code. We have the audio from the microphone. In this case, in the example, I'm using audio from this media player, which is mostly just voices. And this is the waveform of the Morse code as it's coming in from the K3. So the monitor of the K3 is just coming out 1 and 2. Since it's 2-channel audio, so it's not stereo, but there's audio on both channels. So that's why we have both of those channels on the Pi, which is system here. That's why we have them going through here like that. Since we're only sending the same audio on both of these, that we don't need a third channel for coming into here. And this is plenty of audio power, so we're just splitting this mono. Since it's the same mono signal here, that's why we're able to make 2 pass, one for the CW filter and one for the sideband filter. This is actually a graphic equalizer, and this is just a band pass. This is a fader that allows you to, switch upper or lower, which I've already shown you. And let's talk about the delay line here. There's my setting at 40 milliseconds. Again, by the time this reaches the line input of the K3 through this third audio channel here, which on the Pi is right here, and it's going to the system sound card, which is the K3 sound card. I only need 1 channel since it's mono anyway. And then it's just a matter of how good you want to make your voice sound and how much volume, so you don't overdo the ALC and start distorting, and you might get some spurious signals. We can control the rig from here. Just left click or right click on this GRIG. There's the command line. You can see the command lines for the other ones too. The ZITA-J2N, ZITA-N2J, and you just click on the help, and it'll bring up this other stuff. But it's the IP address and the port, so you have to have port numbers that are different. Also out is how I got the K3 zone sound card, which is HW0. I'm using the lowest quality, so it doesn't pressure the CPU. You can see it's running pretty low here. And the J is just to identify that it's a push-to-talk in CW. We're using REALvnc, and I have they offer free accounts for Raspberry Pi owners for personal use. So you don't have to worry about hooking up your router. Just register up to 5 computers, I think, with REALvnc, and then you can find them, and it's able to find them, and then you just click on the client side, you click on the REALvnc, which one you want to connect to of the 5. So we're not using Wine or any Windows VSTs in this particular example, this experimental setup. So I think every one of these that you're seeing here is an LV2 as far as being a plugin. I think that's all I wanted to show. If you needed some iambic Morse code, all you have to do is bring a side tone into the microphone jack right here, and then make sure the audio is cleaned up before it gets to the mic, or after. You just bring in another CAF filter, just bring up another instance of it, and that'll clean it up, and then you can send that voltage over here, and then set up another attenuator like this amp, because this amp can go negative or positive. So you send the full volume to channel 1 on Zeta J2N, and from the mic jack input where you have your side tone, you go through a simple amp first so that you can adjust it as going to system over here, which is this Realtek laptop sound card. So that should be fine. And I think that's just about it. Thank you for watching.